Okay, for the second video, let's talk about some of the problems that we did in our workbook. So we start off the week by doing these problems here on displacement versus distance on page 181. So let's talk about a few of them. Okay, let's talk about the first one. So when it comes to these problems, what you're going to be doing to get to the right answer is that you should draw yourself a little picture, right? So this question is asking us to find the displacement from position 1 to position 2. So here's my little picture here. Right, so my position 1 was 45 centimeters and my position 2 was 33 centimeters. So it's asking my displacement from position 1 to position 2. Because we're going to the left, that means my answer is going to be negative. 45 minus 33 gives me negative 12 centimeters. Now let's talk about the chessboard question. So this is where my king is, this is where my knight is. So it's asking me where is the displacement from king to knight. So because we're moving to the left, my answer is going to be negative. 12 minus 5 gives me 7 centimeters. Let's talk about number 7. So number 7 talks about going from olds to choo-choo and going to sundry. So the distance, right, you're just adding together your length numbers, right? So I got to 156 by adding 97 plus 59. And I got to my 38 kilometers west by adding together negative 97 plus 59. And that's because negative 97, I got negative 97 because it's going 97 kilometers west and 59 kilometers east. Question 9. So it talks about a softball. So here's my little picture here. So I have 7.8 meters east, 9.5 meters east. And that gives me 17.3 meters east. And I have 9.1 meters west and 8.2 kilometers west. And that's just given from the question. To determine my distance, we're going to just add my length values together, right? So 17.3 plus 17.3 gives me 34.6. My displacement, I'm just adding together my two vectors here. Going west is negative and going east is positive. So my answer becomes 0 meters. And obviously 0 is at the origin, so there's no direction. Next, we talked about some velocity/speed problems on page 183 to 184. So that's just these problems here and these problems here on page 183 to 184. So we started off easy, right? For the first question here about the stunt bike, we're asked to find the speed. We give you a distance value, we'll give you a time value. So altogether, to calculate the speed, we're going to go 39 divided by 3, and that gives us our speed value. Now let's talk about some of the other problems here, right? Similar idea. So let's talk about question 15. So question 15 is one where there's initial conditions. So the sprinter starts at 12 meters east at a time of 1.8 seconds. Next, the final condition, right, where he ended up with was 56 meters east and 6.7 seconds. So he started here and he ended here. So when we have two sets of conditions, we've got to expand out our formula. So when it comes to question 15, when we're trying to find the velocity, right, this is my final conditions, this is my initial conditions. So if you punch out in the calculator, you should have got 9.0 meters per second east. Okay, so we also continue. Let's talk about a couple of problems in the back. So let's talk about question 17. So 17, right, once again, we're giving initial conditions and final conditions. So to find out our velocity, we're going to first get a time value, right? Because we can't punch in 3:09 p.m. to 2:15 p.m. We gotta get it to either hours or seconds. So what I did was that I first got the minute value from 3:09 p.m. to 2:15 p.m. It was 54 minutes. So next I divided by 60 to get to my hour value. I kept it hours because we have kilometers readings, right? So I didn't want to do the extra conversion. To get to our velocity, you're going to do negative 116 because we're going south, minus 35. Remember, if you minus a negative, it's the same as plus a positive, right? Because the two negatives cancel out. This negative cancels out with this negative. So it's going to be negative 116 plus positive 35 because the two negatives cancel out, divided by our 0.9 hours. And you should have gotten 90 kilometers per hour. You could also answer this as 90 kilometers per hour south because the south means telling you that it's going south. These problems here on the bottom here are even more simpler here, right? So, so all of them are asking for either speed or velocity. So when it comes to that, you're just dividing your distance value by the time, or you're dividing your displacement by the time. Next, we talked about some acceleration problems. So that's just these ones here. So that's on page 192 to 193. Like these problems here, right here. So to determine the acceleration, right, we're just dividing our velocity over the time. So we start you out simple. Right, we're giving you a velocity and a time, so all you're doing is dividing the 145 by the 4.48 to get to your acceleration value. Question 26 becomes a little more complicated, and that's because we have a final velocity and an initial velocity. But what you're doing is you're doing one extra step, and that's you're subtracting your final velocity from your initial velocity divided by however long it took for you to get there, right? So it took us 5.5 seconds. So that's where my math came in. So this becomes 25 meters per second north, right? Because our direction was going north. All right, so I want to talk about question 27, and that's because there's something has to do with significant digits. So question 27 talks about the professional baseball pitcher right here, this one. So my initial velocity was negative 45 because according to the question, we're going in the negative direction. And our final velocity was 30 meters per second because we're going in a positive direction according to how they framed their question. So once again, it's going to be 30 minus negative 45. If you minus the negative, this becomes positive because the two negatives cancel out. And your answer is going to be 62.5 meters per second squared. However, because we only use two digits in our math, we gotta use proper significant digit rule. This is a case where you can round it off and you still meet your significant digit rule. And that's because if I round this to 63, it is approximately 62.5, so that's allowed. But you can also put in scientific notation, but I just feel like this is a little quicker than putting it in that way. But this is a situation where you don't have to use scientific notation, and that's because you can just simply round this off number to 2 digits. Versus if you had a really big number, you can't round it off to 2 or 3 digits. Like for example, 1, 2, 3, 4, 5. Like this is a really big number and you can't round this off to 2 or 3 significant digits. And that's when you have to use scientific notation. And this is why I picked question 27, is to illustrate when you need to use significant digits and when you don't need to. This is when you don't need to, and that's because you can round this answer off. This is when you need to, because you can't round the answer off to 2 or 3 digits. It's too big. Okay, so looking ahead, so we have these problems here, 28 through 31. So similar idea here. So question 28 talks about the child that rolled up the ball up a hill. So when it comes to this, you're giving an initial velocity and a final velocity. So you got to subtract your final from your initial divided by the time, and that's how you get to your acceleration. So question 31, it asks us for the time. So here's where we have to do a little bit of algebra to bring the time at the top, and you gotta bring the acceleration to the bottom here to calculate for the time. Right, just a quick reminder how that math work. Right, we started out with this. We're trying to find the time. So what you gotta do here is multiply this by delta t, and then we're gonna multiply this also by delta t. Divide this by a, divide this by a. That way we isolate. So then there's only delta t on the left hand side. So that's why to get to my time value, I did velocity divided by my acceleration. And once you do that, you recognize that the meters per second cancels out with the meters per second. However, there's two of them. So essentially one of the s's get canceled out and the other one gets brought up to the top. So I'll show you what that means, right? So you have meters per second divided by meters per second squared. So when you divide by a fraction, is equivalent to when you multiply it by a fraction, right? So this means this, right? So your meters cancel out and this cancels out. So you're just left with 1 second value. So that's why our answer is 6.35 seconds. Like that. The last part of our week, we talk about this part here. So, okay, so when it comes to this, right, our ticker tape is in intervals of 0.1 seconds. So our time is going to be 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and so forth. And what you got to do here is just take your ruler. I got to measure out the displacement here. So I measured this to be 1.05, this to be 2.11, and this to be 3.15. So what that means is that this is the position from 0 to 0.1 seconds. This is the position for the 0.2 seconds from here to here. This is the position from 0.3 seconds. This is the position from 0.4 seconds. This is the position from 0.5 seconds. So that's how I got to these numbers here. So some of you might have gotten the little different numbers, like maybe for this one you might have gotten 4.2. This one you might have gotten 3.3. That's okay, as long as you're in the ballpark, that's fine. And because I noticed that you guys only have 9 tick marks, so I just added one on because there's one extra space. So this is a uniform motion, so I just approximated the approximate distance that I saw in my other tick gaps. So this is how I got to my position number, right? So once you have these two data sets and you make yourself a little table, next you're gonna put it into a data table. Next you're gonna graph it, right? So remember, this is your y-axis. This is your x-axis. So time and your position. So next thing I did was I plotted my points and I drew my line of best fit. And remember to put a title on here as well. After that, it's asked us to calculate the slope. So for this one, I picked this point here and this point here. So what I did was rise over run. And if when I punched out my calculator, I got to 10.6 centimeters per second. And some of you might have gotten a little different number. As long as you're between 9 to 11, I'll take that. So that's basically where we wrapped off this week. Have a nice weekend. That's all for now.